All right, before we get into conducting our titration, we need to make sure it's all set up ready to go. And part of that setup is ensuring that you have properly clean glassware. So let's look at some things to do with setting up your glassware, ensuring they're ready for titration. Right, to set your glassware up, in order to be very analytical and precise with measurements, we need to make sure they are clean and that they are free of contaminants. So we're going to look at this in two perspectives. We're going to look at how do you set up your burette and your pipette, and then we're going to be looking at the conical flask. So let's get into the first section, burette and pipette. Alright, so to clean our burette and pipette, it's a two-step process here. Okay, what we want to do is we want to make sure that they are clean of any contaminants. We've got to clean the outside of the glassware and of course the inside of the glassware. As we're going to be rinsing it with deionized water. Then the second thing is then we're going to be rinsing with the solution that you need, right? So let's look at the burette first. So the burette here, we've got to make sure that there is no contaminants inside the burette. So we want to rinse that with water. So what you do is you get a filter funnel. You make sure the stopcock of the burette is closed. You don't want to be pouring solution down and it ends up all over the bench. So ensure the stopcock is closed. You want to get the filter funnel, pour some deionized water into the burette. Okay, once you've got some of that, you place it over the top of a beaker. You open the stopcock and close it because that allows some water to go through the mechanism underneath the stopcock and cleans that out. You want to do that a couple of times. Then what you want to do is you want to invert, or I should say just place the glassware in a horizontal fashion and roll it between your fingers, and because that enables the water to coat the inside of the burette, and then you can dispense that. You can either dispense it through the stopcock, which is slower, or you can then just invert it into the sink or into a waste beaker. And of course you've got to do that 3 times. That ensures the inside of the burette, top and below the stopcock, and including the stopcock mechanism, is nice and clean. Now that is removal of contaminants, but now of course we want to rinse it with the solution that you are using. If you don't do this, of course you're going to dilute your primary standard that you place in there. So let's say that you are using some HCl, that you have a standard solution of HCl. That is going to be your titrant. So now what you want to do is you want to rinse the burette 3 times with your titrant in the same procedure that we did for deionized water, but this time you're using your titrant, because that ensures that any water that's left inside the burette is not going to dilute the titrant that you use in your titration. So we do that 3 times. Now your burette is all ready to go. You put it in a burette clamp, you fill it up, you start at the 0 mark, and then just to remove any bubbles which will affect the volume of your titrant that you add in your titration, tap it a few times and then just turn the stopcock a couple of times to ensure that there is liquid all the way through that stopcock mechanism and there's no bubbles, and then you record the starting volume of your burette. Right? We haven't done any titration reaction yet, so you want to record the starting volume so that you can do a initial and a final volume measurement to calculate how much volume you have added to your conical flask when you do your titration. So the burette is all ready to go. Now we want to do the same thing with our pipette. Our pipette, of course, has been cleaned on the outside, but now we've got to clean it on the inside. And so what we want to do is exactly the same thing. We want to clean the inside 3 times with distilled water. Now it's a bit too narrow to add distilled water from the top, so what we want to do is of course use a pipette bulb filler, and we want to suck up some clean distilled water in a fresh glass beaker and do that to about 1/3 of the volume. Make sure the inside of the bulb that you're measuring is covered as well. You then do the same thing. You hold it horizontally, twist your fingers around, and make sure that water coats every surface inside that pipette. Then of course you want to dispense that into a waste beaker. You do that 3 times for your distilled water. Now that our pipette's cleaned with deionized water, we now got to do the same with our analyte. And so we want to make sure that our analyte coats the complete inside of our pipette. And so we do the same procedure, but this time using small samples of our analyte. So we've got our pipette nice and clean. Well, what about our conical flask? Well, our conical flask has to be, of course, clean of contaminants. We don't want any contaminants in there. But we can just rinse this with distilled water. Remember, inside our conical flask, we're going to have a certain number of moles of our analyte that's going to react with our titrant. If we have excess solvent in there, or water, that's not going to affect how many moles react with the titrant. So we don't need to ensure that we rinse and dry this out, but we do need to ensure that we have deionized water to ensure there's no contaminants in there. Okay? Having clean glassware is something that you should be checking as well. The whole point of volumetric analysis is that you want to measure precise volumes of a titrant added to your analyte. If you have unclean glassware, you can see that it beads here, and we've got volume of water stuck to the sides. So when you add it to your analyte, you're going to have an incorrect volume measurement because some of it's going to be stuck on the sides of the burette. So having a clean glassware does actually make a difference. Well, what are some common errors in preparation of glassware, and what effects does it have on titration? Well, volumetric pipette. We've already said that you need to rinse that with a solution that you're using, the analyte. But if you rinse it with water, what effect does that have? Well, it dilutes the solution, so its concentration will no longer be known accurately. That's the whole point that you're trying to be doing, is working out the concentration of the analyte that you put into your flask, right? Filling a pipette from the stock solution, as we said before, may introduce a contaminant into the stock solution. Instead, fill it from a beaker, right? So we've mentioned that previously. Pour it into a beaker and then draw up your aliquot, which just means a small volume of your analytes. So draw up your aliquot from a small beaker. Burette, well, if we rinse it with water, we've said before that that would dilute the solution of known concentration, your titrant, and therefore you won't really know an accurate concentration of your titrant anymore. Okay, we've already said that make sure that you fill this underneath the stopcock area, okay, because we want to make sure that is clean. Sometimes when people fill up their burette with their known solution, they have the stopcock closed, they fill it up, but below the stopcock there is air, and they forget about that, and so when they start their titration, the first part of what they add is just air. So after you've filled your burette, get a waste beaker, put it underneath, open the stopcock. That allows the titrant to fill up all the burette. Now we have the burette volume measurement as accurate as can be. If you rinse it with the analyte, that would increase the number of moles in the flask and therefore give you an inaccurate reading. Okay, what we want to do is we want to ensure that we rinse it with water. Sometimes, if you might think, oh, well, how about we rinse it with the titrant? Well, no, because if you put the titrant in there, as soon as you put your aliquot of your analyte in there, you're going to get a reaction, and that's going to prevent you determining the exact number of moles from the titrant that you add. So there's some common errors to watch out for. All right, let's do a quick question to test your brain cells on these concepts. This is a multiple choice question from the 2021 paper. Have a go, and we'll go through it to see how you've gone. All right, did you get B? And could you explain why? All right, so let's check out the thinking behind this and use this question to extract the information and review the concepts that we've talked about. So it says, a student used the following method to titrate an acetic acid solution of unknown concentration. Right, so that means that we're going to be titrating it, and it says with standardized diluted sodium hydroxide. So here we have our sodium hydroxide, up here is our titrant, and our analyte is our acetic acid. Now it says they first of all rinse the burette with distilled water, so we have a problem with that straight away, right? Because that's going to dilute the titrant, right? We know that we should rinse it with water to get rid of contaminants, but then we have to rinse it 3 times with, of course, the solution that you're going to be using. In this instance, it's the titrant sodium hydroxide. So there's our first problem. If we dilute it, that means you're going to need more volume to react with the analyte, right? So straight away, that's going to mean it's going to be a higher amount of volume of titrant that we need. Fill the burette with sodium hydroxide solution, yeah, that's fine. Rinse the pipette and the conical flask with acetic acid solution. Well, only one of those are true. We want to rinse the pipette because we're pipetting our analyte solution from our stock solution into the conical flask, so that's good. We want to clean it with water, but then rinse it with the solution that you're using. The problem is we're rinsing the conical flask with the acetic acid. that's going to leave behind more analyte inside the flask before you put in your aliquot of your analyte. So it means that you're going to put in more moles of acetic acid than what you would normally have in that aliquot, and that means you're going to need more of the titrant. So we've got 2 spots there, 1 and 2, that's going to increase the volume of titrant that we normally would have, and therefore B is the correct answer. All of these are completely fine. So that's just a multiple choice question, testing your understanding of correct procedure when it comes to preparing your glassware. So that's it in this video. We've gone through about preparing your glassware so that you can get the most accurate titration results as possible. In the next video, we're going to be looking at what is a standard solution, because that is what our titrant is. What is a standard solution? How do you make a standard solution? And once we've done that, then we can get into the nitty-gritty of actually conducting a titration. We're all doing this preparation work, so you really understand what's going on with our titration. So make sure that you have your dot points added, your notes are detailed, any diagrams that you have are in your book. Review them frequently, have a go at the worksheet and the Kahoot that's below, check out the study tips as well, and I'll see you in another video. And in the meantime, you can use the posters and study cards at schoolhomeworklab.com to keep those brain cells pumping. Keep your learning visual and revise it frequently. So until the next video, keep studying hard, and I'll see you then.